All right, so let's get started with the first question here. Solve the following equations to find the value of n. Be sure to do your check. So let's start with the first one. It says 5n minus 13 is equal to 18. So we want to find n, so we need to have n on a side by itself. So the first thing we want to do then is get rid of this minus 13. Okay, we want to take it over here. Once we do that, so this is a constant. Once we do that, we'll have a term on the left hand side that has only n. So how will I get rid of this minus 13? I'm going to transpose it, right? Which means I'm going to take it to the other side. It's going to become positive. In effect, what I'm doing is I'm adding 13 to both sides, right? What I do on one side, I do to the next. So you can look at it like that, right? So we're going to transpose this, and when I do that, what I'm going to have is 5n left on the left hand side, and over here we had 18, and now we are adding 13. So now I have 5n is equal to 31. Now I have a coefficient of 5 here, so I need to get rid of that so I can be left with only n. So I'm going to divide by, not n, 5. So this can cancel. But what I do on one side, I've got to do on the other side. And so I'm left with n is equal to 31 over 5. Okay, this is an improper fraction. You may see this as 6 and 1/5 as a mixed fraction. All right, so this is how I do the first question. All right, let's look at part 2. So what we want to do first of all is distribute. So we're going to do 2 multiplied by n and 2 multiplied by minus 1. Minus 1 multiplied by 5, and then minus 1 multiplied by minus 3n. Okay, so that's what we're going to do here. So then I have 2n minus 2 is equal to minus 5 plus 3n. See that? Minus 1 times minus 3n gives me a positive value. So now what I'm going to do is I'm going to take the n and take it over here, the left hand side, and take this constant and take it over here on the right hand side. So I have terms with n on one side, constants on the side by itself. All right, so let's go. So I have 2n minus 3n. Why is it minus? Because over here it was positive, so I transposed it. And over here I have minus 5 plus 2. How did I get plus 2? Because over the left hand side it was negative. Minus 2n minus 3n is minus 1n. Right? We don't normally write the minus 1. But in this case, I will, and I'll show you why. And then minus 5 plus 2 is a minus 3. And now I'm going to divide both sides by minus 1 because I'm not looking for minus n. I'm looking for just n. So what I do on one side, I've got to do on the other side. These cancel, so I'm left with just n is equal to minus 3 over minus 1 is 3. Okay. Now, one thing we did not do in the first one that the instructions clearly said that we needed to do was do our check. So let's do the check for this one. Then we'll go back and do the check for the first one that we did. So we have 2n minus 1 is equal to minus 1, 5 minus 3. And it's very important that we follow our instructions. It clearly states that we need to do our checks. Okay? So that means wherever we see n, we're going to put 3 and see if it works out. So 3 minus 1 is equal to minus 1. 5 minus 3n, and we said n was 3. So over here we have 2. 3 minus 1 is 2. 2 multiplied by 2 is equal to minus 1. 5 minus 9. So this is 4, and this is minus 1. 5 minus 9 is minus 4. So 4 then is equal to minus 1 times minus 4, which is positive 4. So this checks out. All right. So we need to go ahead and do the same thing with the previous one, right? So let's go back and let's do that. So the original problem was 5n minus 13 is equal to 18. Okay. So we did 6 and 1/2, 31 over 5. So 5 multiplied by 31 over 5 minus 13 is equal to 18. We're multiplying here, so these cancel. So I'm left with 31 minus 13 is equal to 18. 31 minus 13 is 18. So you can see we have shown our checks. All right, we're good so far. Okay, so now let's look at the third one. X over 2 plus x over 3 is equal to 5. Again, we are solving for x here. I know the instruction says find the value of n. It's just a typographical error, right? We're solving for the variable here, which is x, okay? So what we can do here, since they're both x variables, is we can add these, right? So we're going to find the least common denominator. In that case, it's 6, right? How did I do that? 2 and 3 both go into 6, and it's the smallest number that they can both go into. So if you look at the multiples of 2, what we have is 2, 4, 6, 8, and so forth. Look at the multiples of 3. What we have are 3, 6, 9. See that right here? They're both going to 6. It's the smallest common denominator, right? So we have found the LCM, right? We can talk more about how to find LCM if you have some issues with that. You can probably find some videos for that also on my YouTube channel, or just contact me, okay? So once we found the LCM, which is 6, what I'm going to do is I'm going to say 2 into 6 is 3. 3 times x is 3x. So 3x plus 3 into 6 is 2. 2 times x is 2x. And this again is still equal to 5. So now I have 3x plus 2x is 5x over 6 is equal to 5. Okay? Now what I'm going to do, in order to get rid of this denominator here, I'm going to multiply this by 6. Why am I going to do that? Because they can cancel. See, 6 multiplied by 5x over 6 is basically 6 over 1 multiplied by that. 6 is a whole number. A whole number is a fraction, it's just that number over 1. So once I do that, I see they cancel. I'm left with 5x over 1, which is just 5x, right? 5x over 1, which is just 5x, which is what I want. So now let's get back over here. So, but if I multiply 6 on the left-hand side, I've got to do it on the right-hand side. Now what's going to happen on the left-hand side is that these are going to cancel. So I'm going to be left with just 5x is equal to 30. I'm not finished though, am I? Because I'm not looking for 5x. I'm looking for x, right? So my next step from here will be to divide over here by 5, which means I've got to divide over here by 5, right? These cancel, so I'm left with x is equal to 6. Now this is what I believe my answer is. But what does it tell us to do? Check our answer. So our answer we're saying is x is equal to 6. Okay? So x over 2, this is the original problem, plus x over 3 is equal to 5. So wherever we see x, we'll plug in 6 and see if that works out for us. So 6 over 2 plus 6 over 3 is equal to 5. 6 over 2 is just 3, isn't it? Because 2 can go into 2 once, 2 can go into 6 3 times. And 6 over 3 is just 2, isn't it? So 5 is equal to 5. This checks out. We've completed number 1. Okay, so 1b. Convert 4/9 of a right angle to 90 degrees. So first of all, what we should know is this. What is a right angle? A right angle is equal to 90 degrees, right? And so what is 4/9 of a right angle? It is 4/9 of 90 degrees, right? And we know what this off means, right? It means multiply, right? So 4/9 multiplied by 90 over 1. This is 1, and this is 10. That's 40 degrees. So we do all this because we're expecting that our students understand what we're asking them to do. So really what we're asking us to do is to convert 4/9 of a right angle to degrees. And this is our process, and this is our answer. We have converted 4/9 of an angle to degrees. Okay? So let's now look at part 2. So part 2 says you want to convert 135 degrees to revolutions, right? But what's a revolution? One revolution is a full time around the circle, and we know that that's 360 degrees. So basically we're saying 360 degrees is equal to 1 revolution. So 135 degrees is equal to x revolution. Okay? So this is pretty much a ratio problem, right? So when we get a problem like this, there are two ways we could do this, right? We could do a cross multiplication, which means we'll do 3 times 360 times x, then we'll do 135 times 1. And of course, we'll solve for x. So let's go that route. So 360 multiplied by x is equal to 135 multiplied by 1, which of course is just 135. And so I have 360x. So of course I want to find x now. So if I divide 360x by 360, but of course that means I have to divide the other side by 360. Okay? Alright, so now we're left with just x here. Okay? And when you reduce this, you could reduce this by whatever you see first. What I mean by that, I mean right here, what you could do is you could divide this by 4 to 5. 4 to 5 goes into both of these, but you might not see that initially. What you might see initially is that they're both divisible by 5. And in fact, they are. When you divide 135 by 5, okay, you're going to get 24. When you divide 360 by 5, you're going to get 72. Okay? And you can reduce that further by 3, can't you? Actually, when you divide 135 by 5, you actually get 27. Apologies on that. You get 27 here. And here you get 72. And you can reduce this further by 3, so this becomes 9. And this becomes 24. And you can reduce this further by 3. And 3 into 9 is 3. And 3 into 24 is 8. So the answer here is 3/8 revolutions. Okay? That's your answer there. Again, going back to this reduction, right? The first thing you might see as a student is 135 over 360, right? The denominator is an even number, but the numerator is not. So they're not both divisible by 2. So that's not the route to go, but they're both divisible by 5. So you might want to start there in reducing, okay? And that's a wrap for question 1. Okay, so we're going to add 228 degrees, 24 minutes, 32 seconds. Double quote, represents seconds. Single quote represents minute. And we're not talking about the time. Okay, we're talking about angles. So we're going to add that to 112 degrees, 52 minutes, 48 seconds. So first, let's move over here, right, to just take a look at what we should know. There are 60 seconds in 1 minute. There are 60 minutes in 1 degree, right? So again, keep in mind, you can always pause this video, rewind this video, and play it again. Take your proper notes. So let's take a look at how we utilize this information. If I have 85 minutes, that is actually the same thing as 1 degree, 25 minutes. Now, how did we get that? Because 85 minutes is the same thing as 60 minutes plus 25 minutes. But we know that 60 minutes is 1 degree. Well, you have 1 degree plus 25 minutes, and we actually write that like this: 1 degree, 25 minutes. Okay, so keep this principle in mind. Again, this is probably a good point to pause the video and go back over that if that went by a little fast for you. Okay, all right, so now we're going to utilize that and then perform our math. All right, so let's add. 2 plus 8 is 10, carry the 1. 1 and 3 is 4, and 4 is 80. So now I have 80 seconds. But 80 seconds is actually 1 minute plus 20 seconds. So what I'll do is I'll bring down the 2 and I'll add the 1 to the minutes section. See, this section right here is the minutes section, right? Right here, notice I have minutes under minutes. Okay, all right. So I added the 1 minute, so I carried the 1 over and left the 20 that I got from the 80. Got to be careful here. All right, let's proceed. So now 1 plus 4 is 5. 5 plus 2 is 7. I carried nothing over, but now I have 2 plus 5 is 7. So here I have 77 minutes. But I know that this is 1 degree and 17 minutes, right? Because I take the 60 out of here. So I'm going to carry that 60 to the degree, just 1 degree. And here I'm left with 1, right? This is from the 77, right? Okay. So now I have 1 plus 8 is 9. 9 plus 2 is 11. Carry the 1. 1 plus 2 is 3. 3 plus 1 is 4. Nothing to carry. 2 plus 1 is 3. So my answer is 341 degrees. 17 minutes, 20 seconds. Okay, so let's look at part B. So what we're going to do now is we're going to multiply what we have here by 4. So this might look a little confusing, but it's not, because all we're going to do is multiply. Okay, that's all we're going to do. So when I multiply 4 times 25, so this is seconds, I get 100 seconds. And when I multiply 4 times 34, I get 136 minutes. And when I multiply 4 times 137, I get 548. And you might just want to check that the math is correct there. Make sure the math is correct there. Now, we're done, aren't we? No, we're not done. We're not done because this cannot be more than 60 and this cannot be more than 6. Otherwise, we have to carry. Okay? So that should be very simple for us to fix, right? So what we'll do here is we'll realize that this is 100, so we'll carry 60 over, so we'll be left with 40 here. So this is 40 seconds, and we carry 1 here, which means we have 137, right? So we have 137 minutes. We have 548 degrees. Now, we still can't stop there, right? Because this can't be more than 60, right? So when you look at 137, that's really equal to 120, right? Minute plus 17. And 120 minute is actually 2 degrees plus 17 minute, right? So I bring down this 40 seconds and I'm left with 17 minute. But now I have to carry 2 degrees over here. 2 degrees. So now I'm left with 550 degrees. Okay. Now, if you're working with revolutions as it appears you are, you're still not done. Why am I saying that? Because you know that a revolution is 360 degrees. So 550 degrees can't be greater than 360. So I've got to take 360 out and carry it over to one revolution. So this becomes one revolution. Remember, a revolution is 360 degrees. One revolution plus 190 degrees. And so this then, right, becomes, let me put it underneath here. One revolution, 190 degrees, 17 minutes, 40 seconds. Okay, so let's look at the subtraction. Okay, first of all, we've got to set this up properly. It says subtract this number from this, which means this is the one that goes to the top because we're taking it from this number. Okay, so we set it up properly. And then we remember the principle here. The principle here is that we're working separate, even though it's one problem. So we'll deal with the seconds first. And when you look at the seconds, you realize you can't get 56 from 9. So you have to borrow, right? Borrowing works the same way as it does in regular math, right? So I have to borrow a minute from here, which is in fact 60 seconds. So when I borrow 1, instead of having 9, I'm going to have 6 to 9. Instead of having 12, I'm going to have 11 over here. All right, so let's do it. So what I'm going to do here is I'm going to borrow 1 from this 12. So I'm going to put 11 here. And then this now becomes 6 to 9. So now 6 from 9 is 3. 5 from 6 is 1. So I have 13 seconds. Now, similarly, I now have 11 minutes minus 37 minutes. That can't happen. So I have to borrow 1 degree. So I'm going to be left with the 70 degree there. But now instead of having 11, I'm going to have 11 plus 60 because I borrowed a degree, which is 60 minutes. So 11 plus 60 is now 7 to 1. So now I have 7 to 1. Okay. Now what I have here is 7 to 1 minus 37. That's doable. So now I can perform this action. But I can't get 7 from 1. So I have to borrow from this 7 here. This becomes 6. This becomes 11. This is now normal math. 7 from 11 is 4. Okay. 3 from 6 is 34. So this becomes 34 minutes. Now remember, pause the video, rewind it a couple times if you need to. This is not a live session saying that they're to ask questions or ask me to go over it again, but it's there. You have it on video, so there's an advantage there. Okay? And then we come over to the minute, and when you subtract 70 minus 28, you will end up with 42 degrees, right? And of course, you can go ahead and do that the normal way, 70 minus 28, right? Where you borrow from here. This becomes 6, this becomes 10. 8 from 10 comes 2, 2 from 6 becomes 4. Okay, normal computation skills apply here. All right. Okay. So let's now proceed to part D. So what we're going to do here now is we're going to divide, but we're going to divide all the way from the left side. So first we'll do the revolutions. And if we have any remainder, then we will convert that to degrees. And if we have any remainder, we'll convert that to minutes and so forth. So let's get started, right? So what happens when you divide 5 revolutions by 3? You get 1 revolution, but then there's a remainder, isn't there? A remainder of 2 revolutions. But 2 can't divide by 3. So we'll convert this 2 into degrees. And so this is really 1 revolution with a remainder of 2 revolutions, which is 720 degrees. Remember, 1 revolution is equal to 360 degrees. So when I have a remainder of 2 revolutions, that's really 720 degrees. Okay? So now I'm writing my answers here. So what I have here is I have 1 revolution. And now I have 720 degrees left over. So what I'll have to do now is I'll have to add that 720 degrees to what I already have here, which is 224. And then I'll divide that by 3. So that becomes 944 degrees divided by 3. Okay? So in the interest of space, what I'm going to do here is I'm just going to let me get rid of that right there. See if I can fit this up in a corner somewhere. Again, because this is a video, you can always pause and go back, so you don't have this space issue. Even if I erase this, it's not erased on your stuff. Okay. All right. So here we are again. We have 944 divided by 3. Okay. 944 divided by 3. And when I do that, okay, you should be doing that as well where you are. Okay, I get 314. 314 degrees, but I get a remainder of 2. Okay, so you could say plus 2 degrees if you will, right? Which is remainder 2, right? So now, again, my answer, I have 314 degrees, but now I have 2 degrees left over. But 2 degrees is equal to 120 minutes, right? And then now I need to add that 120 minutes to 42 minutes. So I have 120 plus 42 minutes, and that's divided by 3, and that's really 152 divided by 3. This is minutes, and when you divide that, 152, wait, is it 152? Sorry, this is 162. Apologies, 162. Okay, let me fix that for you. Apologies. 142 plus 42. 120 plus 42 is 162. 162 minutes divided by 3. When you divide that, 3 into 16 is 5. Remainder 1. So then I have 12. 3 into 12 is 4. So this is 54 minutes. There is no remainder. This becomes 54 minutes. And now I have this at 27 seconds divided by 3, which is just 9 seconds. So this is now 9 seconds. And that's it. That's it. So you might want to rewind this and take it piece by piece, but that's it. That's number 2 for you. All right, number 3. Let's make these in bold, these variables in bold, the subject of the equation. Okay, so let's start with the first one. Y is equal to mx plus c. So we're trying to get x on a side by itself. So the first thing I want to do then is get rid of anything else. So first I want to get rid of the c, so I'll transpose it and take it over here, okay, on that side. So over here it's positive, over here it's going to be negative, okay. This becomes y minus c is equal to mx. That's my first step. My second issue is this m right here. I got to get rid of that. To get rid of that, I've got to divide the right hand side by m. But what I do on one side, I've got to do on the other side. So once I cancel these out, I'm left with x is equal to y minus c over m, and that's it. That's number one. All right, let's look at the second one. Q is equal to PR minus R over T, and we need to make P the subject equation, which again means we want P on a side by itself. So the first thing I'm going to do is get P out of this fraction. So this is a fraction. So there's a denominator here. So what I'm going to do is I'm going to multiply over here by T. See, these would cancel. But if I do it on one side, I've got to do it on the other side, right? So now these cancel. And on the right side of this equation, I'm left with P squared minus R. On the left side, I'm left with Q multiplied by T, which is QT. Now I have a new problem. This R, I don't want it on the side with my P because I'm looking for P, so I'm going to transpose it. So when I take it on the left-hand side, it's going to be the opposite sign, so it's going to be plus. So I'm left with QT plus R is equal to P squared, right? So there's one more thing I need to do is get rid of this square right here, right? This square right here is a problem. So to do that, I've got to take the square root of both sides. So I've got to take the square root of this, which would cancel out this. But if I do that there, I've got to do it on this side. So what I'm left with then is QT plus R under the square root sign is equal to just P. And that's it. I have made P the subject of the equation. Okay, so let's look at the third one. All right. So we're looking for n. We want to make n the subject of the equation. So n is caught up in a fraction, which is caught up in a square root sign. So the first thing I need to do is square both sides to get rid of the square root sign. So if I square this side, which means everything in here gets squared, right? Then I've got to do the same thing here. I've got to square this side. When I do that, I'm left with t squared is equal to 5m over 12n. All right, so I've made some progress here. I've gotten rid of the square root sign by squaring, but now I'm still having some issues because now 12n is in the denominator. All right, so what I'm going to do here now is I'm going to multiply by 12n on this side. That's going to cancel this, but because I have to multiply on 12n on the other side, it reintroduces the 12n. So these cancel. And on the right hand side, I'm left with just 5m. Remember, guys, you can slow this video down. That's the beauty of a video, right? You can slow this down and say, whoa, 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 you went too fast there. If we were doing a live tutorial session, you could have said that to me. Sir, you're going a little too fast or so. Or, sir, can you just repeat that? But the video allows you to go back and repeat itself. So you kind of have a little control there over me, if you will. All right, so on the left-hand side, I have 12 and t squared, okay? Now, I'm going to divide on the left-hand side by 12t squared. That will get rid of this t squared. It will get rid of this 12. But I've got to do that on the other side as well. 12t squared. So when I'm left, when I'm done then, this is gone. This is gone. And lo and behold, I'm left with just n is equal to 5m divided by 12 t squared. Okay? And that's it. That's number 3. All right, so let's look at 3b. I spoke a little too quickly there. I said we were finished with number 3, but there was a second part. Let's look at 3b, okay? It's asking us to find a couple angles here, x, which is this angle here, and y, which is this angle here, okay? So before I get started with that, let me just do a quick review explanation of alternate angles, all right? So this works if I have two parallel lines, okay? So I have two parallel lines. And if I have a line that passes through them, it could be that line, it could have come the other direction, it doesn't matter, right? It doesn't matter. Comes through them, right? So let's look at this one. Now what happens here is that you can see that we can see a couple Z's, right? Here's a Z. Right here. There's another Z. Granted, it's backwards, right? All right. So the first thing I want to remind you of is that the angle here is equal to the angle here. All right. Similarly, the angle here is equal to the angle here. Okay. So just keep that in mind. All right. Also, keep that in mind, right? Also keep in mind that within the Z, this angle is equal to this angle, right? So again, let me trace that Z for you. See that Z right there? And what that also then means is that this angle is equal to this one, right? And again, that's from the same Z, right? See that? So those two angles are equal. Now, why is that important? Because the first thing I can see here, let's go to the problem now, is I can see we have two parallel lines, right? Tells us right here, okay? And I can see a Z here. You see that Z right here, right? So this angle here must be equal to this angle. So you found the first one, X is equal to 54. So let's just write that down, right? So X is equal to 54 degrees. These are alternate angles, right? Why is that important to state? Well, because it says to state it, doesn't it? It says to state it. Give reasons for your answers, right? So that's X. So what about Y then? How do we go about finding Y? Well, here's what we know. Going back to our Z, okay? This is our Z. This is another Z, which means this angle is equal to this one right here. So what does that mean? That means that this angle here is equal to 115 degrees, 115 degrees. Now, what do we know about a straight line, right? So take note here, right? This is a straight line, which means that if you take a look at this angle Y and 115, they must add up to 180 degrees, right? They must add up to 180 degrees. So then Y then is 180 degrees minus 115 degrees. Okay, so Y is equal to 65 degrees, and I gave you your reason, and that's it. That's part B. Okay, so let's jump to number 4. And so we're going to simplify using the laws of indices. So let's look at the first one. 6 to 4, 8 to the 6, y to the minus 4, all raised to the 1/2. Which basically means we're taking the square root of all of this, right? Now what this 1/2 on the outside means is we're taking the powers inside here and multiplying them by 1/2. So the first thing I'm going to do is I'm going to realize here that 6 to 4 is 8 squared. So this is 8 squared, 8 to the 6th power y to the minus 4 power to the 1/2. So again, when we're going to distribute this 1/2 inside. So then this becomes 8 squared to the 1/2, 8 to the 6th to the 1/2, y to the minus 4 to the 1/2. And then we're going to multiply these exponents. And our rule that we're using here is a to the x raised to the y power is a to the x multiplied by y. So we multiply the exponents here. Now this is a little different than a to the x multiplied by a to the y, in which case what we do is we add. Okay, so be careful not to make this mistake. Take a look at what we have. This is this. So this becomes 8 to the 2 multiplied by 1/2, and then this is multiplied by a to the 6 multiplied by 1/2, and then this is multiplied by y to the minus 4 multiplied by 1/2. So this becomes 8 to the first power. This becomes a to the third power, and then this one becomes y to the minus 2 power. Okay? So this is 8a to the third power, y to the minus 2, which may be written as 8a to the third power over y squared. Now, how did I do this part? How did I get this below? Because there's a rule that says a to the minus x is equal to 1 over a to the x, right? And I applied that rule right here, the y to the minus 2 power. And that's it for part 1 of number 4. All right, let's look at number 2 of number 4. So what I have here is, remember the rule that says a to the x multiplied by a to the y is equal to a to the x plus y. I'll utilize that. I'll also utilize a to the negative x is equal to 1 over a to the x. It's the same thing as saying, it's the same thing if we have the other way around, which means 1 over a to the x is equal to a to the negative x. So we'll utilize these two things, right? So let's go here. So this is 8 to the first power. So what I'm seeing here is 8 to the first power. They're all base 8, right? So plus 3, because you're multiplying 8 to the first power times 8 to the third. So let's add the exponents. Plus a negative 7, right? We're multiplying here. All divided by 8 to the negative 5, right? So let's work up the top here first. So in the numerator, I have 1 plus 3 is 4. 4 plus a negative 7 is negative 3. So I have 8 to the negative 3 divided by 8 to the negative 5. Now, remember, there is a rule that tells us how to divide. It says a to the x divided by a to the y is equal to a to the x minus y, which means I just have to subtract the powers, right? So this is equal to 8 to the minus 3 minus a minus 5. You gotta be careful here, right? You're subtracting whatever the power is below. That power is not 5, it is minus 5. So a minus of minus 5, which gives me 8 to the minus 3 plus 5, which gives me 8 squared. Okay? So you may leave it like that, or perhaps your teacher wants you to actually perform this, which would then be 64. And that's it. That's the second part of number 4, and that's your mock exam. So you could touch base with me on here, okay? and perhaps we can set up a session where I can help you further moving on. But good luck with your exam.